On March 7, 1944, at 0830 hours, Vice Admiral Jizaburo Ozawa stood on the bridge of the aircraft carrier watching the morning sun rise over Linga Road's anchorage off Sumatra. The ship beneath his feet represented 32 months of labor, 16,000 tons of steel, and the entire remaining hope of the Imperial Japanese Navy. Taiho was the only purpose-built fleet carrier Japan had commissioned since the war began. One carrier in 32 months. Ozawa had received intelligence reports 3 days earlier. The Americans had commissioned 17 new fleet carriers in that summer. 17, and they had stopped counting the smaller ones. The numbers made no sense. They violated everything Ozawa understood about industrial capacity, shipyard limitations, and construction. Japan had spent decades building the finest carrier force in the world. The Americans had supposedly started from nothing. Yet somehow, in lesser time than it took Japan to build one, Taiho, American shipyards were launching new carriers every month. Ozawa knew what those numbers meant. They meant Japan had already lost the war. The shooting would continue for another 16 months. Thousands more men would die. But the outcome was decided by mathematics, steel, and welding torches in shipyards 7,000 miles away. The question that kept Ozawa awake at night was simple. How did they do it? Japan entered the war with the most powerful carrier force ever assembled. 6 fleet carriers, 2 light carriers, all modern, all battle-tested. The American Pacific Fleet had 4 carriers. Japan had numerical superiority, tactical superiority, and 2 decades of carrier doctrine development. The Japanese Navy had been building carriers since 1922. They understood carrier operations better than any navy in the world. Their pilots were the best trained. Their aircraft were proven in combat. Their tactics were refined through years of war in China. American carriers were untested. American pilots were inexperienced. American doctrine was theoretical. On paper, Japan should have dominated carrier warfare for years, but by December 1941, Japan knew it faced a fundamental problem. The United States had an industrial capacity 10 times larger than Japan's. Raw steel, shipyard capacity, machine tool manufacturing. Everything favored America by ratios that seemed impossible to overcome. Admiral Isoroku Yamamoto understood this better than anyone in the Japanese High Command. He had served as a naval attaché in Washington. He had seen American factories, American shipyards, American industrial infrastructure. He told the Japanese government that Japan could win battles for 6 months, perhaps a year. After that, American industrial power would overwhelm anything Japan could produce. The government ignored him. They believed its spirit could overcome steel. They believed tactical brilliance could defeat numerical superiority. They believed Japan's warrior culture gave them an advantage that factories could not match. They were wrong. The first carrier Japan lost was Sho, sunk on May 7, 1942 during the Battle of Coral Sea. She went down after taking 13 bomb hits and 7 torpedo strikes from American carrier aircraft. Shoho was a light carrier, 11,000 tons, converted from a submarine tender. She carried 30 aircraft. Her loss was significant but not catastrophic. But 1 month later, Japan lost 4 fleet carriers in a single day at Midway. Akagi, Kaga, Soryu, Hairu, gone. Sun sunk B. American dive bombers in a battle that lasted 6 minutes. Those 4 carriers represented 20 years of Japanese naval development, 40,000 tons of irreplaceable combat power, and 250 aircraft. The Japanese naval staff in Tokyo received the reports and immediately began calculating. Akagi had taken 4 years to build. Kaga had taken 6 years. Soryu took 3 years. Hugh took 4 years. Average construction time. For years per fleet carrier. 4 ships lost. 17 years of construction time to replace them. Japan had 3 major shipyards capable of building fleet carriers: Yokosuka Naval Arsenal, Kure Naval Arsenal, and Kawasaki Shipyard in Kobe. All 3 were working at maximum capacity building destroyers, cruisers, submarines, and merchant ships to replace combat losses and support offensive operations. To replace 4 carriers would require dedicating all 3 yards to carrier construction exclusively for nearly 6 years. That meant no destroyers, no cruisers, no submarines, no merchant ships. Japan could not afford that. The war required daring. The naval staff made a decision. They would build 1 new fleet carrier, Taiho, which had been laid down before Pearl Harbor. They would convert merchant ships and sea planetenders to light carriers. They would design a new class of smaller, cheaper carriers that could be built faster. The plan looked reasonable on paper. Taiho would provide fleet carrier capability. The conversions would provide interim replacements. The new Unru-class carriers would eventually restore Japan's numerical strength. It was a logical plan, carefully calculated, properly resourced. It failed completely. Taiho's keel had been laden July 10, 1941. The ship was launched on April 7, 1943. She was commissioned on March 7, 1944. 32 months from Kalaying to commission. That was actually fast for a Japanese fleet carrier. Shukaku and Zuikaku, laid down in late 1937, had taken 44 months and 45 months respectively. Japan had improved its carrier construction timeline significantly. 32 months was an achievement worth noting. The Americans commissioned USS Essex on December 31, 1942. Her keel had been laid on April 28, 1941, 20 months. The Essex was larger than she displaced 27,100 tons, standard compared to Taiho's 29,300 tons. She carried 90 aircraft compared to Taiho's 75, 20 months. The American Shad built a larger, more capable carrier in 37% less time than Japan's fastest construction program. But that wasn't the shocking part. The shocking part was that Essex was just the first. In January 1943, Lexington was commissioned, then Yorktown, then Bunker Hill, then Intrepid, then Hornet, then Franklin. By December 1943, the Americans had commissioned 11 Essex-class carriers, 11. In 1 year, Japan commissioned Taiho, 1 carrier. In 1944, the naval staff in Tokyo studied the intelligence reports. They checked its numbers repeatedly. They assumed American propaganda was inflating production figures, but reconnaissance aircraft confirmed it. Photographic inkling confirmed it. Intercepted radio traffic confirmed it. The Americans were launching carriers faster than Japan could train pilots to fly from them. How? The answer started with a man named Henry Kaiser. Kaiser had never built a ship in his life before 1941. He was a construction engineer. He built dams, roads, bridges, the Hoover Dam, the Bonneville Dam, the Grand Gully Dam. Massive concrete structures that required moving mountains of material and coordinating thousands of workers. In 1941, the United States Maritime Commission needed cargo ships, hundreds of cargo ships, thousands of cargo ships, ships to carry food, fuel, ammunition, tanks, aircraft, troops across the Atlantic and Pacific. Traditional shipyards said it would take 6 months to build a cargo ship. That was normal. That was how shipbuilding. You laid a keel, built up from the bottom, riveted steel plates together, installed engines, launched the hull, then spent months finishing the interior, 6 months per ship. The Maritime Commission needed 2,000 ships. That would take 1,000 years of shipyard capacity. Kaiser looked at the problem differently. He didn't see he saw structures, steel structures that could be broken down into components prefabricated in separate facilities, then assembled at the shipyard. Instead of building ships from the bottom up, one piece at a time, Kaiser proposed building ships from sections welded together. Traditional shipbuilders said it was impossible. Riveting was proven technology. Welding was risky. Welded seams could fail. Cracks could propagate through welds and break a ship in half. Kaiser said he would take the risk. He built 4 shipyards in Richmond, California, on San Francisco Bay. He hired workers from across the country. Most had never seen a ship before. Many were women. Many were African men who had been excluded from shipyard work. Kaiser didn't care about experience. He cared about organization. He divided ship construction into modules. Each module was built in a separate prefabrication shop. Deck sections, bulkheads, engine rooms, superstructures, everything broken down into pieces that could be built by workers who only needed to know how to weld that specific piece. The modules were built on their sides or upside down. Whatever orientation made welding, they were moved to the shipway with massive cranes lowered into position, welded together. The first Liberty ship Kaiser built took 196 days. The 10th took 45 days. By 1943, Kaiser's yards were completing Liberty ships in an average of 42 days. The record was 4 days, 15 hours, and 29 minutes. The SS Robert E. Perry, built in November 1942 as a publicity stunt to demonstrate what was possible. for days to build a ship. Traditional shipbuilders had said 6 months. The technique worked for cargo ships. Could it work for carriers? Kaiser proposed converting his methods to escort carrier production. Small carriers, built on merchant ship hulls, designed for convoy protection and ground support rather than fleet. The Navy was skeptical. Carriers were complex. They required specialized equipment, trained workers, years of expertise. Kaiser said, give him a chance. His Vancouver, Washington shipyard laid the keel for the escort carrier Casablanca on November 3, 1942. The ship was launched on April 5, 1943, commissioned on July 8, 1943, 8 months from keel to commissioning. The Navy wanted 50 escort carriers. Kaiser delivered 50 carriers in 14 months, one a carrier every 8 days. The Japanese naval staff in Tokyo received these reports and assumed they were errors. One carrier every 8 days was physically impossible. It violated every principle of naval construction, but the reports kept coming, and they were confirmed by combat encounters. By late 1943, American carrier task forces were appearing in the Pacific with numbers that made no tactical sense. 12 carriers, 15 carriers, 18 carriers in a single task force. Japan's entire carrier strength was 6 ships. The Americans were deploying task forces larger than Japan's entire carrier fleet. Where were these ships coming from? Not just Kaiser's escort carriers. The Essex-class fleet carriers were raring in squadron strength. The secret was the same prefabrication technique applied to fleet carrier construction. Newport News, Shipbuilding, in Virginia, had been building carriers since the 1930s. They knew it took years, but they learned from Kaiser's cargo ship methods. They started prefabricating carrier components, hull sections, hangar decks, flight decks, island superarches, all built in separate shops, then moved to the shipway for final assembly. They placed riveting with welding wherever possible. Welding was faster, required less skilled labor, created lighter structures. They standardized designs. Every Essex-class carrier used the same plans, the same components, the same. Workers learned to build one module, then built dozens of identical modules. They streamlined construction sequences. Instead of waiting for one section to be completed before starting the next, multiple sections were built simultaneously in different locations, then brought together. USS Franklin, built at Newport News, was laid down on December 7, 1942, launched on October 14, 1943, commissioned on January 31, 1944.13 months from keel to commissioning. That wasn't even the record. Several lesser-class carriers were completed in 14 to 16 months. The average was 18 months. Japan's Taiho took 32 months. American shipyards were building fleet carriers as fast as Japanese shipyards, and they were building more than twice as many. By the time Taiho was commissioned in March 1944, the Americans had 17 Essex-class carriers in service or under construction, 17-1. The ratio was worse when you include light carriers and escort carriers. America was operating more than 100 carriers of all types. By mid-1944, Japan had 9. The Japanese Navy tried to adapt. They ordered 14. These were smaller than Taiho, simpler to build, designed for mass production. The Unru class was based on the pre-war Hue design, modernized but using proven technology and standard components. They displaced 17,150 tons, carried 6.5 aircraft, could make 34 knots. They were supposed to be Japan's answer to the Essex-class. 3 were completed. Unhyo, Amajikatsura Junhyo, was commissioned on August 6, 1944. Amagi on August 10, 1944. Katsu on October 15, 1944. 3 carriers commissioned within 10 weeks. It seemed like progress. Japan was accelerating carrier production, except the Americans commissioned 9 Essex-class carriers in the same 10-week period. The Japanese couldn't catch up. Every time they accelerated production, the Americans accelerated faster. Worse, Japan was running out of resources. Building a carrier requires steel, lots of steel. An Essex-class carrier contained approximately 27,000 tons of steel plate, structural steel, armor plate. The United States produced 60 million tons of steel in 1943, 80 million tons in 1944. Japan produced 8,004,000 tons in 19,436 million tons in 1944. The American steel industry was producing 10 times more steel than Japan's entire industrial capacity. That steel gap rippled through every aspect of naval construction. American shipyards had steel. They could build hulls, armor, machinery, everything they needed. If a section was damaged or incorrectly built, they scrapped it and built a new one. Japanese shipyards rationed steel. Every plate was precious. Mistakes had to be fixed, not replaced. Construction slowed because workers spent time repairing injuries instead of moving forward. American shipyards had machine tools, lathes, drill presses, milling machines, all modern, all powered, capable of precision work at high speed. Japanese shipyards rationed machine tools. Many were old, worn out, breaking down. Replacement parts were scarce. Production slowed because machinery failed, and workers waited for repairs. American shipyards had welding equipment. Thousands of welding stations, oxygen, acetylene torches, electric arc welders, all standardized, all maintained. Japanese shipyards rationed welding. Many yards still relied on riveting because they lacked sufficient welding capacity. The gap extended to trained workers. American shipyards employed 2 million workers by 1943. Many were new to shipbuilding, but they were trained quickly using standardized methods and simple repetitive tasks. Kaiser's Richmond shipyards alone employed 90,000 workers at peak production. That was more workers than all three of Japan's major naval shipyards combined. The Richmond workforce looked nothing like a traditional shipyard crews. 40% were women. Many had never held industrial jobs before. They were farm wives from the Midwest, teachers from rural towns, office workers from cities across America. They learned to weld in 2 weeks of training. They learned to operate cranes in 3 days. They learned to read blueprints in a week. Traditional shipbuilders said these workers couldn't possibly build quality ships. They lacked the years of experience required for precision metalwork. But Kaiser's prefabrication system didn't require years of experience. It required workers who could do one specific task repeatedly and accurately. A welder in the Richmond yards didn't need to understand ship architecture. She needed to know how to weld a specific type of seam on a specific type of joint. The blueprints told her where the jigs and fixtures held everything in position. She moved from one piece to the next, welding identical joints dozens of times per shift. Repetition created expertise. After a month, workers became fast. After 2 months, they became precise. After 3 months, they could work faster than traditional shipwrights who had spent years learning their trade. The Japanese couldn't replicate this model. Japanese shipyards employed 300,000 workers. Many were skilled craftsmen, but they were spread thin across dozens of projects. Training new workers was slow because experienced workers were too busy to teach. More critically, Japanese industrial culture emphasized craftsmanship over standardization. A skilled Japanese shipfitter took pride in custom fitting each piece, making minor adjustments to ensure perfect alignment. That approach produced beautiful ships, but it was slow. American workers didn't custom fit anything. Parts were manufactured to precise specifications in prefabrication shops. They either fit together or they didn't. If a part didn't fit, it was rejected and a new one was made. That approach produced functional ships fast. The difference in philosophy reflected the difference in industrial capacity. Japan had limited steel, limited machine tools, every piece had to be used. Waste was unacceptable. Custom fitting ensured nothing was wasted. America had abundant steel, abundant machine tools, abundant workers. If a piece was wrong, they made another one. Speed mattered more than perfection. Both approaches had merit, but in wartime, speed won. The Americans had enough workers that they could specialize. One crew built bulkheads, another crew built decks, another crew installed propulsion machinery. Specialization in speed. Japanese shipyards needed workers who could do everything. Shipfitters had to fit hulls, install machinery, run electrical systems. Generalists were flexible but slower. Newport News, Shipbuilding, the yard that built most Essex-class carriers, developed specialized assembly areas, front carrier components. One building 500 feet long was dedicated to fabricating flight deck sections. Giant overhead cranes moved steel plate from storage racks to stations where workers with acetylene torches cut the plates to specifications. The cut plates moved to edge. preparation stations where workers beveled the edges for welding, then to assembly jigs where plates were aligned and tack welded together. Finally, 2 welding stations where teams of welders completed permanent welds working in sequence, each welder responsible for a complete flight deck section 120 feet long by 90 feet wide took 8 days from raw steel to finished component. That same section built using traditional methods with a single crew working in the shipway would take 6 weeks. Another building fabricated elevator assemblies. Carrier elevators were complex mechanisms, hydraulically powered, capable of lifting 30-ton aircraft from the hangar deck to the flight deck in 30 seconds. Traditional shipyards installed elevators piece by piece in the carrier hull. It was difficult work in cramped spaces, requiring precise alignment and extensive testing. Newport News built entire elevator assemblies in a dedicated shop. The assembly was tested, adjusted, and verified before it ever reached the ship. When installation time came, cranes lifted the complete elevator into position. Connection to hydraulic systems took days instead of weeks. Propulsion systems received similar treatment. Each Essex-class carrier needed 4 sets of turbines, 8 boilers, reduction gears, propeller shafts, and thousands of feet of steam piping. Installing this machinery traditionally took months. Newport News created propulsion module assemblies. Each module contained 1 complete turbine set, 2 boilers, and all associated piping pre-assembled and tested. The modules were built in a separate facility completely outfitted with instrumentation and controls. They were test-fired using temporary steam connections to verify performance. When the carrier hull was ready, cranes lifted the entire propulsion module into the machinery space. Workers connected steam lines, electrical cables, and control systems. The entire installation took 3 weeks instead of 3 months. This modular approach extended to radar systems were pre-assembled and tested. Complete radar masts with antennas, transmitters, receivers, and power supplies were built in electronic shops, then installed as units. Crew accommodations where berthing compartments with bunks, lockers, lighting, and ventilation were assembled in specialized shops, then lifted into position in the hull. Even small items were standardized. Every hatch was identical. Every door, every ladder, every ventilation duct, all built to standard specifications that fit standard openings. Workers didn't measure and cut and fit each piece individually. They grabbed pre-made components from storage, bolted or welded them in place, and moved to the next task. The result was carriers that went from key laying to launch in 6 to 8 months, then spent another 6 to 8 months in outfitting and trials before commissioning. Total time 14 to 16 months from start to operational carrier. Japan couldn't match this because they lacked 3 critical elements. First, they lacked the industrial infrastructure for true mass production. Prefabrication required factories that could produce thousands of identical components with precision. American industry had that infrastructure from decades of automobile manufacturing, applianceman for crant, and consumer goods production. Factories were designed around assembly lines, standardized parts, and interchangeable components. Japanese industry had limited experience with mass production. Most manufacturing was small-scale, custom work-oriented. Precision parts came from specialized machine shops, not assembly lines. Attempting to replicate American prefabrication methods would have required building entirely new factories, training entirely new workforces, and developing entirely new supply chains. Japan didn't have time, resources, or expertise for that transformation. Second, they lacked the raw material capacity. Prefabrication is wasteful. You cut more steel than you need. You make parts that don't fit and have to be scrapped. You overstock components to ensure you never run short. When Kaiser's Richmond yards built a Liberty ship, they ordered 15% more steel than the ship required. The extra steel covered waste, mistakes, rejected parts, and inventory buffers. That approach worked when steel was abundant. It failed when steel was scarce. Japan couldn't afford 15% waste. Every ton of steel plate was precious. Waste had to be minimized. That meant custom fitting. That meant slower work. That meant longer construction times. Third, they lacked the transportation infrastructure. American prefabrication worked because components could be manufactured anywhere in the country and shipped to shipyards by rail. A bulkhead section built in Pennsylvania could be on a flatbed rail car to Newport News within 24 hours. 2 days later, it was being welded into a carrier hull. Japan's rail network was limited. Most heavy components moved by coastal shipping. That shipping was under constant attack by American submarines. A turbine built in Kobe might take 2 weeks to reach Yokosuka by ship. If the transport was sunk, which happened regularly, the turbine was lost and a replacement had to be built. Supply chain vulnerabilities crippled Japanese naval construction more severely than any other single factor. The gap extended to logistics. American shipyards received steel, aluminum, copper, rubber, electronics, everything they needed by rail and truck from factories across the continent. If one supplier had problems, there were. Japanese shipyards depended on shipping. Steel came from mills in Korea and copper came from mines in the Philippines. Rubber came from the Dutch East Indies, all transported by merchant ships that were being sunk by American, but submarines at increasing rates. By 1944, Japan was losing merchant shipping faster than shipyards could replace it. Critical materials weren't arriving. Construction programs were delayed because shipyards were waiting for steel plate, turbine blades, electrical cable. Taihoa had been designed with 8 boilers and 4 turbines, producing 160,000 shaft horsepower. 2 of Voinru carriers, Katsuragi and Osbo, were built with destroyer engines because turbine manufacturers couldn't produce fleet carrier power plants fast enough. Those carriers could only make 25 knots instead of 34 knots. Slower carriers meant less tactical flexibility, less ability to evade attacks, less ability to close with enemy forces or retreat from danger. The Americans faced no. Every Essex-class carrier had identical propulsion systems, 150,000 shaft horsepower, 33 knots, no exceptions. The Japanese also faced Appalachia training crisis. Building carriers was only half the problem. Training pilots to fly from them was equally critical. Before the war, Japan had the best naval aviators in the world. Pilots trained for 2 years before their first carrier landing. They practiced navigation, gunnery, formation flying, night operations, carrier approaches. By 1943, Japan didn't have 2 years. They didn't have 1 year. American submarine warfare was destroying Japanese merchant shipping. That meant less fuel for training flights. Pilot training programs were shortened from 24 months to 12 months, then to 8 months. Pilots were graduating to fleet squadrons with 100 flight hours instead of 500. They could fly and shoot, but they lacked the experience to survive combat against veteran American pilots. Saburo Sakai, one of Japan's top aces with 64 kills, was pulled from combat in early 1943 to serve as a flight instructor. He was shocked by what he found. The training program was overwhelmed. Instructors had too many students. Classes were rushed. Fundamental skills were being skipped because there wasn't time to teach them properly. Sakai later wrote that they were told to rush men through. Forget the fine points. Just teach them how to fly and shoot. The pilots who graduate from these abbreviated programs were sent to carrier squadrons to fill out air groups. They were brave, dedicated, willing to die for their country, but they weren't ready. At the Battle of the Philippine Sea in June 1944, the Japanese sent 450 carrier aircraft against American task forces. American fighters shot down 300 of them. The Americans called it the Great Marianas Turkey Shoot. The battle demonstrative writing, wrong with Japanese carrier operations. In 1944, Japan committed 9 carriers to the battle. 3 fleet carriers, Taiho Shikaku, Zuikaku, 6 light carriers, Kitosi, Kyoto, Juno, Hyo, Rio, and the newly commissioned Unria. Those 9 carriers embarked 450 aircraft. That was less than half the aircraft capacity. Those carriers were designed to hold. Japan simply didn't have any aircraft to fully equip its carriers. Worse, the pilots flying those aircraft were inadequately trained. Before Through, Japanese carrier pilots trained for 2 years before their first combat deployment. By June 1944, pilots were deploying to carriers. After 6 months of training, they could take off and land. They could fly basic formations. They could operate their aircraft systems, but they lacked the combat experience to serve against veteran American pilots flying superior aircraft. American Task Force 58, commanded by Admiral Mark Mitchell, fielded 15 carriers, 7 Essex-class fleet carriers, and 8 light carriers. Those carriers embarked 956 aircraft, more than twice the Japanese total. And those American aircraft were superior to their Japanese counterparts. The F-6F Hellcat fighter had a maximum speed of 380 mph, compared to the A-6M0's 340 miles per hour. The Hellcat could dive at 450 miles per hour without structural failure. The Zero's maximum dive speed was 360 miles per hour. The Hellcat was armored, pilot armor, self-sealing fuel tanks, armored engine. It could absorb tremendous battle damage and continue flying. The Zero had no armor. A single burst of machine gun fire through the fuel tank would ignite it. Pilot casualties were catastrophic because they had not. The Hellcat mounted 650 caliber machine guns with combined firepower of 1,800 rounds per minute. The Zero mounted to 20 mm cannons and two 7.7 mm machine guns. Good armament, but less sustained firepower than the Hellcat. Most critically, American pilots in June 1944 were combat veterans. The average American fighter pilot in Task Force 58 had 200 hours of combat flight time. Many had 300 hours or more. They had fought at Terroir Truck, Hollandia, and dozens of smaller engagements. They knew their aircraft's capabilities. They knew how to exploit the Hellcat's advantages. They knew how to fight Zeros and win. The average Japanese pilot had 20 hours of combat flight time. Some had none. They were flying their first carrier operation against the largest, most experienced naval aviation force ever. The result was predictable. On June 19th, Japan launched its first strike wave at 7:30 a.m. 69 aircraft. American radar detected them at 150 miles. Fighter directors vetoed 40 Hellcats to intercept. The Hellcats hit the Japanese formation, 40 miles from the carriers. They shot down 42 aircraft in the first 10 minutes of combat. The surviving Japanese aircraft continued toward the carriers. They encountered a second wave of American fighters, then a third wave, then anti-aircraft fire from the screening destroyers and cruisers. 80 aircraft broke through to the carriers. They scored no hits. For aircraft and to their carriers, Japan's first strike lost 94% of its aircraft. The second strike, launched at 8:56 a.m., fared no better. 109 aircraft met Thesum layered defense. American fighters destroyed 97 of them before they reached attack range. The third strike, 107 aircraft, achieved a single bomb hit on the battleship South Dakota, causing minor damage. The fourth strike became Some aircraft found American carriers but were driven off. Others never located the enemy and returned to their carriers with bombs still attached. Of 450 aircraft launched, 300 were shot down. Another 50 crashed, attempting to land on Carriers in darkness after the battle. Japan lost 350 aircraft and their pilots in one day of combat. America lost 29 aircraft. That exchange ratio, 12-1 in America's favor, reflected the cumulative advantages of superior aircraft, superior pilots, superior doctrine, and superior radar direction. It also reflected the consequences of Japan's failed carrier construction program. If Japan had been able to build carriers as fast as America, they could have deployed 20 or 30 carriers to Philippine Sea instead of 9. Even with inferior pilots and inferior aircraft, 30 carriers would have deployed over 1,000 aircraft. Sheer numbers might have overwhelmed American defenses, but Japan had 9 carriers, and by the end of the battle, 3 of them were gone. Japan lost 3 carriers in that battle: Taiho, Shokaku, and Hyo. Taiho served for just 3 months after commissioning. She was hit by a single torpedo from the American submariner Vola on June 19th. The damage should have been manageable. Japanese damage control doctrine was adequate for torpedo hits, but a young damage control officer made a critical error. He ordered the ship's ventilation system turned on to clear gasoline fumes from the hangar deck. The ventilation system spread the fumes throughout the ship instead of venting them overboard. 6 hours after the torpedo hit, a spark ignited the gasoline vapor. The explosion tore the ship apart. She sank in minutes, taking 1,272 men with her. 32 months to build, 3 months in service. Gone. Shukaku, one of Japan's most successful carriers, veteran of Pearl Harbor, Coral Sea, Santa Cruz, was hit by 4 torpedoes from the submariner. She sank 7 hours later. Ho was hit by aerial torpedoes and bombs. She caught fire, lost power, and sank. Japan lost 3 carriers in one day. The Americans lost none. By late 1944, Japan's carrier force was at the Battle of Lee Gulf in October. The Japanese committed their remaining carriers as a decoy force. 4 carriers, with almost no aircraft aboard, sailed north to draw American carriers away from the main battle area. The plan worked. American carrier aircraft attacked the decoy force, sank all 4 carriers, but the sacrifice achieved nothing. American escort carriers in later Gulf fought off the Japanese surface fleet anyway. The decoy operation cost Japan its last carrier sphere. No strategic gain. Zuikaku, the last of the 6 carriers that attacked Pearl Harbor, went down on October 25, 1944. She had survived 3 years of combat. She was sunk because Japan no longer had enough aircraft or pilots to defend her. By November 1944, Japan had new operational fleet carriers. America had 28. The American industrial advantage wasn't just numbers, it was systemic. When an Essex-class carrier was damaged in combat, it sailed to a naval yard for repairs. The repairs were completed in weeks or months, using prefabricated replacement sections, standardized parts, and massive repair facilities. USS Franklin was hit by 2 bombs on March 19, 1945, while operating off the Japanese coast. The bombs penetrated the flight deck and exploded in the hangar, triggering secondary explosions from fueled and armed aircraft. The fires raged for hours. 87 men were killed. Pleship was dead in the water, listing, burning with magazines threatening to explode. Any other navy would have abandoned ship. Franklin was clearly lost, but American damage control teams fought the fires, stabilized the list, got the engines running. Franklin sailed to Pearl Harbor under her own power at 14 knots. From Pearl Harbor, she transited to the Brooklyn Navy-Yard for tour repairs. The ship arrived at Brooklyn on April 28, 1945. The war ended before she could return to service, but she survived. That level, aftermarch control was impossible for Japan. Japanese carriers hit by major attacks usually sank, or were scuttled. Japan lacked the repair facilities, the replacement parts, the trained damage control teams to save heavily damaged ships. The difference between American and Japanese industrial capacity showed up in every aspect of carrier operations. American carriers had radar. Type SK air search radar could detect incoming aircraft at 90 miles. Type SM height-finding radar could determine altitude. Fighter directors used radar to vector interceptors onto incoming strikes before they reached the fleet. Japanese carriers had limited radar. Early models schooled detect aircraft at 30 miles under ideal conditions. Night operations and bad weather degraded performance significantly. Japanese fighter directors relied on visual sighting and radio reports from picket ships. American carriers had proximity-fused anti-aircraft shells. The VT fuse used a miniature radar to detect nearby aircraft and detonate the shell automatically. Proximity fuses increased anti-aircraft effectiveness by 5 to 10 times compared to contact or time fuses. Japanese carriers used contact and time fuse. Shells had to hit the target directly or be timed to explode at the right altitude. Both methods were far less effective than proximity fuses. American carriers had better aircraft. The F-6F Hellcat fighter could outperform the A-6MO in almost every category. Better speed, better climb rate, better diving speed, better protection, better armor. Japanese carriers still lead on the Zero, which hadn't been significantly upgraded since 1941. The Zero was lighter and more maneuverable than the Hellcat, but it was slower, more fragile, and lacked the firepower to destroy heavily armored American aircraft quickly. American carriers had better doctrine. Fighter sweeps cleared enemy airspace before strikes. Combat air patrols protected the fleet from incoming attacks. Radar-directed intercepts brought fighters into position before enemy strikes arrived. Japanese carrier doctrine relied on fill-out assault. Launch everything, hit the enemy with maximum force, hope to sink carriers before they could strike back. That doctrine worked at Pearl Harbor when surprise was complete. It failed at Midway, when American carriers were waiting. It failed at Philippine Sea when American radar gave early warning and American fighters slaughtered the incoming strike. By 1945, the Japanese Navy had effective airlift to exist as a fighting force. Japan still had battleships, cruisers, destroyers, but without carriers for air cover. Those ships couldn't operate in areas where American carrier aircraft could reach them. The few remaining Japanese carriers were relegated to the training duties or transport roles. Because Japan lacked the pilots and aircraft to operate them effectively. The United States Navy had more carrier power than every other navy in the world combined. Task Force 38, operating Japan in July 1945, included 17 fleet carriers and 6 light carriers. Those carriers embarked more than 1,500 aircraft. The entire strike force could have been assembled, launched, and recovered in under 2 hours. Japan had exactly nothing to counter that level of air power. American carrier strikes ranged freely over Japan, hitting airfields, factories, ports, naval bases, anything that moved. Japanese fighters were outnumbered 10-1 or 20-1. The war ended on August 15, 1945. Japan had commissioned 6 carriers during the war, 3 UNRU-class fleet carriers, 3 converted light carriers. America had commissioned 24 Essex-class fleet carriers, 9 Independence-class light carriers, and over 100 escort carriers. The final ratio was roughly 20-1, 20 American carriers for every Japanese carrier built during the war. That ratio told the story of how industrial capacity determined the outcome of the Pacific War. Japan entered the war with the finest carrier force in the world, built over 20 years by the most experienced architects and shipbuilders in Asia. America entered the war with an untested carrier force built by shipyards that had to learn carrier construction on the fly. But America had something Japan couldn't match: industrial capacity, raw materials, technological innovation, the ability to learn, adapt, and scale production to levels that seemed impossible. The lessons from the carrier construction race extended far beyond World War II. Industrial capacity matters more than tactical brilliance. Japan had better carrier doctrine in 1941, better pilots, better aircraft, better operational experience. They won every battle for the first 6 months, but tactical advantages erode. Pilots die. Aircraft become obsolete. Doctrine evolves. Industrial advantages compound. Every new carrier America built made it easier to build the next one. Every trained worker made training the next worker faster. Every standardized component made the supply chain more efficient. By mid-1943, American carrier construction had become a self-reinforcing system. Shipyards were completing carriers faster than they could train crews for them. Japan never achieved that momentum. Every carrier they built consumed resources needed for the next one. Every worker trained took time from production. Every component standardized required retooling factories that were already overloaded. The gap widened exponentially. In early 1942, Japan had 8 operational carriers. America had 3. By mid-1943, Japan had 6 operational carriers. America had 14. By mid-1944, Japan had 7 operational carriers. America had 32. By early 1945, Japan had 0 operational carriers. America had 39. The progression wasn't linear. It was American carrier strength doubled, then tripled, then quadrupled, while Japanese strength declined. That pattern repeated across every category of naval construction. Japan built 6 fleet carriers during the war. America built 24 Essex-class carriers. Japan built 3 light carriers during the war. America built 9 Independence-class light carriers. Japan completed no escort carriers during the war. America completed 77 Casablanca-class escort carriers plus dozens of other escort carrier types. Total carrier construction. Japan produced 9 carriers during 3.5 years of war. America produced 110 carriers in the same period. The ratio was roughly 12-1. 12 American carriers for every Japan. But even that ratio understates the actual gap. American carriers carried more aircraft, had better radar, better anti-aircraft defenses, better damage control, better everything. An Essex-class carrier could operate 90 aircraft. A Runrius carrier could operate 65 aircraft. An Essex-class carrier could make 33 knots. Some Japanese carriers equipped with emergency destroyer engines could barely make 25 knots. An Essex-class carrier had comprehensive radar coverage. Japanese carriers had limited radar that often failed at critical moments. So the 12-1 numerical advantage translated to roughly 20-1 in actual combat capability. 20 American carriers worth of combat power for every Japanese carrier's worth. That level of superiority made naval combat in the Pacific one-sided after mid-1944. Japanese surface forces couldn't operate within range of American carriers without being destroyed. Japanese bases couldn't function within range of American carriers without being neutralized. Japanese supply lines couldn't function within range of American carriers without being The Pacific War became a war of American carrier aviation bombing Japan. Intense mission while Japanese forces watched helplessly from behind defensive perimeters that shrank daily. By July 1945, American carrier task forces operated off the Japanese coast They launched 1,000 aircraft strikes against Japanese cities. Japanese air defenses Japanese fighters were outnumbered 50-1. The war ended not because of atomic bombs, though those provided a convenient excuse for Japanese leaders to surrender. The war ended because Japan had no military capacity left to resist. Carrier aviation destroyed that capacity, and carrier production created the carrier aviation that won the war. Henry Kaiser, the dam builder who knew nothing about ships, revolutionized shipbuilding by applying mass production techniques. Newport News, Shipbuilding. The traditional carrier builder learned from Kaiser and cut construction times in half. Richmond shipyard workers, many of them women who had never held a wrench before 1942, built carriers in months that should have taken years. Together, they built a fleet that overwhelmed Japan through sheer industrial power. The Japanese understood too late that they had lost war the moment they started it. Admiral Yamamoto had warned them. Japan could win battles for 6 months, perhaps a year. After that, American industrial power would bury them. He was correct, but even Yamamoto underestimated how quickly American industry would mobilize. He thought it would take America 2 years to build replacement carriers for the losses at Pearl Harbor and Coral Sea. It took 9 months. He thought American carrier production would peak at 8 to 10 carriers per year. America produced 18 carriers in 1943 alone. He thought American pilots would take years to develop the skills to match Japanese aviators. American pilots were outfighting Japanese aviators by early 1943. Less than 18 months after Pearl Harbor. Every assumption the Japanese made about American industrial capacity was wrong. Every assumption underestimated America's ability to mobilize resources, train workers, and produce weapons at scales Japan couldn't imagine. The title of this story isn't quite accurate, but it captures the essential truth. Japan built 6 carriers in 3 years of war. The exact number varies depending on how you count conversions and reclassifications, but 6 is the commonly accepted figure for purpose-built fleet carriers completed during wartime. America built 17 Essex-class fleet carriers during the war year. The Rend quoting is it at the 4. The Leo's exact number is 17, because 8 more were under construction when the war ended, and were completed afterward or cancelled. But 17 understates American carrier production include the Independence-class light carriers. 17 plus 9 equals 26 include the Casablanca-class escort carriers. 26 plus 77 equals 103 include all other escort carrier classes, is over 130 total carriers commissioned during the war. The title says, they stopped counting. That's not literally true. The Navy counted every ship, but the numbers became so large that individual carriers stopped mattering strategically. By late 1944, losing a carrier in combat was tactically unfortunate, but strategically irrelevant. Another carrier would arrive next month. Japan lost a carrier, and it was a national crisis. Prayers were said, memorial services held. Recriminations launched at naval commanders who failed to protect irreplaceable assets. The emotional and strategic response to carrier losses tells everything about the industrial gap between the two. For Japan, every carrier was precious. Losing one meant months or years to replace. For America, every carrier was important. Losing one meant waiting weeks for the replacement already under construction. That difference, more than any battle, or any admiral's genius, or any tactical innovation, determined the war's outcome. Industrial capacity won the Pacific War, not courage. Not sacrifice, not tactical brilliance, not warrior spirit, steel, welding torches, and assembly lines. That lesson remains relevant today for anyone studying warfare, strategy, or international competition. Wars are won in factories long before they are decided on battlefields. The Japanese understood what was happening. Vice Admiral Ozawa, standing on Tayaho's Bridge in March 1944, knew the numbers. He knew Japan had lost. But understanding the problem and solving it were different things. Japan couldn't build more shipyards. They lacked the steel, the machine tools, the workers, the logistics. Japan couldn't train more pilots. They lacked the fuel, finstructures, the time. Japan couldn't increase steel production. They lacked the coal, the iron ore, the transportation capacity. Every aspect of Japanese industrial capacity was constrained by resources that were wearing out. Every aspect of American industrial capacity was expanding. By 1945, American shipyards were launching carriers they didn't need. Some Essex-class carriers were completed after the war ended. They never fired a shot in combat, but they existed. 32 Essex-class carriers were ordered. 24 were completed. 8 were cancelled when the war ended. Japan never built the 14 UNRU-class carriers they planned. They completed 3. 6 more were under construction when the war ended. 5 were never started. The gap between American capacity and Japanese capacity wasn't small. It was absolute. The Pacific War was decided in shipyards, not battles. Battles determined when the war ended. Shipyards determined who would win, and the American shipyards, with their prefabrication techniques, their welding innovations, their standardized designs, their armies of workers who had never built ships before, crushed Japan's naval power through sheer industrial output. The title wasn't wrong. The Japanese built 6 carriers in 3 years of war. The Americans built 17 Essex-class fleet carriers. Stop it counting escort carriers after 100, and still had shipyard capacity left over to build merchant ships, landing craft, and liberty ships by the thousands. That disparity, more than any battle, any strategy, any tactical innovation, determined the outcome of the war in the Pacific. If you found this story compelling, please take a moment to like this video. It helps us share more forgotten stories from World War II. Subscribe to stay connected with these histories. Each one matters. Each one deserves to be remembered. We would love to hear from you. Leave a comment below telling us where you are watching from. Our community spans continents. From veterans to history enthusiasts, you are part of something special here. Thank you for watching, and thank you for keeping these stories.